Hello everyone! It's me again, Teacher Joanne. This tutorial is for statistics and probability, a subject which is intended for grade 11 senior high school students in the Philippines. For today's objectives, at the end of the lesson, the learners will be able to identify the length of a confidence interval and computes for the length of the confidence interval. For today's topic, we have estimation under confidence interval. So to start, let us define some terms. So statistical inference is making a conclusion or generalization about the population based on the study of the samples. Point estimate is a single value that estimates the population parameter, such as the sample mean estimates for the population mean, or the sample standard deviation as estimate for the standard deviation of the population. Then we have confidence interval. It is a range or interval, so with upper and lower limits, used to estimate the population parameter. So confidence level is the probability that the value of the parameter falls within the specified range of values. So next term we have estimator. Is any statistic whose value is used to estimate an unknown parameter. Then we have the estimate. It is the realized value of an estimator. So margin of error refers to the maximum acceptable difference determined by alpha between the observed sample statistic and the true population parameter. And we have length of confidence interval. So it is the difference between the upper limit and the lower limit, or twice the margin of error. So here are some important notes on estimation. So if the population is normally distributed and the sampling distribution of the mean is also normally distributed, even if the sample is small or n is less than 30, so this is also the case of applying the central limit theorem where the population variance is unknown. A large sample is considered when the sample is at least 30. It is also the case applying the central limit theorem where the population variance is known. So in interval estimation, the default alpha is 5% or 95% confidence interval. So we have the confidence interval formula for samples of 30 or more. So here's the formula to estimate, where x bar is the sample mean, then the sigma is the population standard deviation, n equals the sample size, and z alpha over 2 is the confidence coefficient. Next formula we have, so that's E for the margin of error. Then we have the upper limit, so UL is the upper limit, wherein you have the sample mean plus the margin of error. Then we have LL. LL is for lower limit. So to get it, you have to subtract sample mean minus the margin of error. And then to get the length, or L, so that's the length of the confidence interval, so that is equivalent to twice the margin of error, or you simply subtract the upper limit minus the lower limit. Then we have the confidence interval formula for samples less than 30. So here's the formula. So x bar, same thing, is the sample mean. And then S is the sample standard deviation. N is the sample size. T alpha over 2 with value V equals N minus 1 degrees of freedom. So the estimation of the mean is just the sample mean plus or minus T alpha over 2 times the sample standard deviation divided by the square root of N. So for the error and upper limit and lower limit, it's the same formula as what we have for the samples greater than or equal to 30. So what we have here is the t-table. So the values you have at the top, so it has one tail and two tails. So this indicates the significance or the confidence level, which is the alpha. And we have the values in the middle. So you have at the left, it says DF. So that is the degrees of freedom, which is we'll be able to get by subtracting 1 from the sample size. So you would refer to these values of the confidence interval if the sample is less than 30 and the sampling distribution of the mean is not normally distributed. For example, so let's say our sample size is 10. So for the degrees of freedom, so that's n minus 1. So that's why we choose the 9. And let's say that the alpha is 0.05 two-tailed. So the value of the t, so you have 2.262. So that's how we'll be able to locate the value of the confidence interval for samples less than 30. So next values we have at the bottom. So we have the value of the z. So these are the values of the confidence interval if the sample is 30 or more and the sampling distribution of the mean is also normally distributed. And if we are also using the central limit theorem. So example number 1. So Ken owns a shirt printing business. He used 160 pieces as his sample for different designs. The population standard deviation of the price of the shirt is 75 pesos. Suppose Ken wants a 95% level of confidence to determine the mean price of all the shirts he is selling. Compute for the margin of error and his estimates and the length of the confidence interval. So the given we have, so we have the population standard deviation, which is 75. N is 160. Then we have the value of z, which is 95%. And if we refer to the table earlier, so that's equivalent to 1.96. So to find the error, so we use the formula we have earlier. So we just substitute the values. So we have 1.96 times 75 divided by the square root of 160. So we will have 11.62 for the error. So to look for the length of the confidence interval, so we just have to multiply 2 to the error or twice the error. So let's just substitute that 2 times 11.62. That will give us 23.24. So therefore, at 95% level of confidence, the margin of error of Ken's estimate is 11.62 and the length of confidence interval is 23.24. So example number 2. Installation of a certain hardware takes a random amount of time with a standard deviation of 5 minutes. A computer technician installs this hardware on 64 different computers with the average installation time of 42 minutes. Compute a 95% confidence interval for the mean installation time and the length of the confidence interval. So we have the given, so the sample mean is 42. We have the standard deviation of 5, n is 64, and the confidence interval is 95%, so which is equivalent to 1.96. So we'll be using the formula for the estimation. So just substitute the values. So we have 42 minus 1.96 times 5 divided by 64. That will give us the lower limit. And then 42 plus 1.96 times 5 over 64. So that is for the upper limit. So we would have the mean is between 40.78 and 43.23. So to get the length of the confidence interval, so just subtract the upper limit minus the lower limit. So we have 43.23 minus 40.78, which is 2.45. So therefore, we can be 95% confident that the true mean installation time is between 40.78 and 43.23 minutes with a confidence interval of 2.45 minutes. Then we have example number 3. Suppose we would like to estimate the mean amount of money spent on food for lunch by senior high school students in a semester. So we have the following data from 10 randomly selected senior high school. We have the sample mean is 35 pesos and variance is 25 pesos. Compute a 99% confidence interval for the average amount spent on food by the senior high school student. So we have the sample mean is 35. Our sample size is 10. We have the standard deviation of 5. And 99% confidence interval with V 10 minus 1 degrees of freedom. So where do we get the standard deviation? So our given is the variance, and as we know, standard deviation is the square root of the variance. That's why we got standard deviation is equal to 5. So we have the formula for the estimation. So since n is less than 30, and it didn't specify that we are following the central limit or it's normally distributed, so that's why we are using the T formula. So let's just substitute the values. So first we consider the degrees of freedom. So we have our sample size, which is 10. So we have to choose n minus 1. So the degrees of freedom is 9. And then it says 99% confidence interval. So we choose 0.01 under 2 tails since it's estimation, upper limit and lower limit. So we have the value of the t, which is 3.25. Then we can substitute the values. So 35 minus 3.25 times 5 over square root of 10. So that's our lower limit. And the upper limit is 35 plus 3.25 times 5 over square root of 10. So it will give us the estimate. So the mean is between 29.86 and 40.14. So therefore, the average amount spent on food by the senior high school students is between 29 pesos and 86 centavos and 40.14 pesos. So next example, example number 4. The operations manager of a large production plant would like to estimate the mean amount of time a worker takes to assemble a new electronic component. The standard deviation of this assembly time is 3.6 minutes. After observing 120 workers assembling similar devices, the manager noticed that their average time was 16.2 minutes. So construct a 99% confidence interval for the mean assembly time. So we have the given sample mean is 16.2. We have the standard deviation is 3.6 and equals 120. And we have the confidence interval 99%, which is equivalent to 2.576. So we would be using the formula for the estimation, so the upper limit and the lower limit. Then we just have to substitute the value. So 16.2 minus 2.576 times 3.6, divide the square root of 120 for our lower limit. And for the upper limit, 16.2 plus 2.576 times 3.6 over square root of 120. So that will give us, so the lower limit is 15.35 and the upper limit is 17.05 for the estimate of the mean. So therefore, the mean amount of time a worker takes to assemble a new electronic component is between 15.35 and 17.05 minutes. Next example, number 5. So you are a time study analyst in manufacturing. You have recorded the following task times in minutes. So they have 3.6, 4.2, 4, 3.5, 3.8, and 3.1. So what is the 90% confidence interval estimate of the population mean task time? So since we don't have the mean first, so we will be computing that one. So to compute for the mean, so just add all the samples and then divide by the sample size, which is 6. So we have 3.6 plus 4.2 plus 4 plus 3.5 plus 3.8 plus 3.1 divided by 6. We have the value of the sample mean, which is 3.7. And then for the standard deviation, so we know the formula. So x minus the mean squared divided by n minus 1. So just substitute the values again. And we will have 0.39 for the sample standard deviation. Then we have the sample size is equal to 6. And we have the confidence interval is 90% with V 6 minus 1 degrees of freedom. So same formula for upper limit and lower limit. So we have to refer to the t table. We have to find the value of the t. So we have our n earlier, which is 6. So we have the degrees of freedom, which is 5. And then we have the 90% confidence interval. So we have the value, which is 2.015. Then let's just substitute that to compute for the upper limit and the lower limit. So we have 3.7 minus 2.015 times 0.39 divided by the square root of 6 for the lower limit. And for the upper limit, it's 3.7 plus 2.015 times 0.39 divide the square root of 6. And it will give us the estimate 3.38 and 4.02. So therefore, the estimate of the population mean task time is between 3.38 and 4.02 minutes. Now let's check what have we learned. So identify the term described in each of the following items. Number 1. It is a range of or interval with lower and upper limits used to estimate the population parameter. Number 2. It refers to the maximum acceptable difference determined by alpha between the observed sample statistic and the true population parameter. Number 3. It is the probability that the value of the parameter falls within a specified range of values. Number 4. It is the realized value of an estimator. And number 5. It is the difference between the upper limit and the lower limit or twice the margin of error. Now let us check the answers. For number 1, that is confidence interval. Number 2, it's margin of error. Number 3, confidence level. Number 4, estimate. And number 5 is length of confidence interval. So I hope you got all the correct answers. So we're done for today, and thank you very much. I hope you learned a lot and see you in our next lesson. Bye!